Good day everybody and welcome to the STS Studio channel. My name is Marinko Laban and this video is another one in the series of tutorials about the VCV Rack plugins I have developed. This tutorial is about the sine wave VCO or voltage controlled oscillator I developed, and as such this video really focuses on the VCO and its functionality and then a few ideas what you can do with it. It is not a tutorial about the usage of VCV Rack or modular synthesis in general. There are far better and more knowledgeable people like Omri Cohen that can tell you a lot more about this than I may ever dream to be able to do. So please check out channels like Omri Cohen's, link is in the description. If you find this tutorial useful, feel free to like the video, leave a comment. If you have any ideas in how I can enhance the plugin, do let me know as well. The plugin is available, or the module is available for free as part of my STS Studio free VCV Rack plugin, and also where to find the source code. You can find the link in the description. It's available on Git. And it's also available as part of the VCV Rack library. So feel free to download it, and any ideas, thoughts on how to improve it, do let me know. Okay, without further ado, let's look into the module. And I've started up my VCV Rack with a few standard starting points, if you like. I have a mixer with send and return module, an equalizer and plateau as the reverb, which I use quite often. I've already added a few scopes and analyzers because I will be using these to explain a few topics and visualize the signals that we are processing. I'm starting with an ADSR and a VCA from the VCV fundamentals modules, and of course my I/O thingies over there. Okay, let's start with making a sound, and let's find the VCV Rack modules STS Studio, and here you see them in the browser. You can of course type the brand and go to STS Studio, and you will see a bunch here that are still under development, but the ones over here are available in the VCV Rack library. So here we have the Sine VCO. Let's drag it over here and let's connect the volt per octave output to the sine as the volt per octave input, and the output, which I always use green, we connect it to the input of the VCA. I already have the gate connected to my envelope generator, and the envelope result is used to trigger the VCA. So if I press a key, I should be able to hear a sound. And as you can hear, we hear a nice, somewhat dull sound, which is typical for a sine. If you look here at the EQ master, which shows the spectrum analysis of the sound, you see that it basically has one peak, which is around 261 Hertz, which is the C4 note, and that is correct because a sine wave has no harmonics. So in the spectrum analysis you would see a single peak at the specific fundamental frequency of that sine wave. Okay, not so terribly exciting. So we have volt control in, and we have signal out, goes to the mixer via the VCA and the envelope, and we have a sound, and presto. So what do the other buttons do? Let's zoom in a little bit so we can read everything a little bit better. Let's start with the buttons over here. We have a pitch button, and this is where we can tune the VCO. By default it's fixed at C4, which is 261.63 Hertz, but I can simply change it. Let me just push a note, By the way, let's change the envelope a little bit so we have a continuous note. So full sustain, and at the moment I keep the note pressed, it will continue to sound. So let's change the pitch while we do that. And you will see that it changes the pitch as such. I can also do a right hand mouse click and just enter a note, for instance a 5, which is 880 Hertz. And then the VCO is tuned in A5, but again, as said, C4 is the default. So if you double click or run initialize via the right hand mouse menu, it will default to C4, and it will get tuned as such. Fairly straightforward. The phase is something I'm going to talk a little bit later about, because changing the phase does not really have any noticeable effect, which is correct, because it doesn't change pitch or volume or whatever. It just changes the starting point of the sine wave within the single cycle of a sine, and that's only relevant if you combine the sine wave with another signal. We'll do that in a minute. And then of course we have volume, which will basically make the signal louder or softer for this particular VCO. You can use it to blend it with other signals and tune the output volume of the VCO specifically. Okay, so nothing terribly exciting. The other block over here is where you can modulate the pitch, the phase and the volume with some kind of input signal, and you can attenuate the amount of modulation without changing the modulation signal. We'll get into that now, and by doing so I want to add an LFO, a low frequency oscillator, so we can use the LFO to modify or modulate the signal. I'm using the VCV Fundamentals one. So here we have an LFO. Let's just pick the sine as an output, using always yellow for modulation. And let's start with frequency modulation. So I'm going to press a note. Nothing happening right now, but as soon as I start to increase the attenuation, you will see that the frequency modulation becomes more and more extreme. And if I change the frequency, it will do it slower, or it will do it quite a bit faster. Even with extreme versions, you actually come into the FM kind of synthesis realm, if you like, but more about that in a bit. Let's be a little bit more subtle, and here you have a bit of more typical vibration that you would find more useful. So very low attenuation is usually needed here. Again, you can right click and fill in a value like so, which is a more reasonable kind of modulation. The same for volume modulation. We can do the same thing, but then it becomes tremolo instead of vibrato. And the same thing here. You can go into quite extremes, which then becomes more kind of ring modulation, if you like, but also more slower, more subtle, of course, where it's intended for. Interesting is that if you would use a pulse, you would see that you would get more on and off trigger kind of signals, especially if I set the offset to off and switch it to bipolar. So it basically means 0 signal out versus full signal out. You get a quite a very extreme type of tremolo, if you like. Okay, so much for the modulation. By the way, the modulation for both frequency as well as volume, and also for the phase, by the way, is not replacing any changes that you made here. It's basically adding. So if I, for instance, go back to, let's say, some frequency modulation, and I change the pitch here, you will notice that the modulation is added on top of the base pitch, which is set here. And the same applies to volume and phase modulation. Okay, now modulating phase. What was that all about? Let me start demonstrating that by first adding another Sine VCO, and I'm going to first demonstrate the output of my sine signal here, and here you see the scope displaying the sine signal based upon the frequency that it has. I've switched trigger on. Now let me add the, sorry, wrong color, add the second VCO, and let's also give that a color. And here you see now that we have two sine signals. One is from VCO number 1 and one is from VCO number 2, obviously. They both play a note to the output signal. So let's also drag the output signal to the second scope, so we can see what the combined signal is. And here you see that the combined signal is actually an addition of both sine waves. When you combine multiple waves, you basically superimpose each signal on top of each other, you add, and that's where you get the combined signal. Now let's tweak the phase a bit and see what happens here. And here you see that the position of one sine wave towards the other is actually changing. And so it doesn't influence the sound of the individual sine, that doesn't change. But when you add them together, you will see that it does influence the sine wave. And in case of two perfect sine waves of the same frequency, if you change one of the phases, so the relative starting point towards each other, they influence the volume because they neutralize each other partly, or they strengthen each other partly, but the frequency doesn't change because the frequency of the individual sine waves is the same. So in this case, changing one phase of one sine wave influences the volume. But it becomes more interesting if we change the pitch of one of the sine waves. So let's change the C4 for this sine wave into a C3. So it's still a C, but then it's an octave lower. And now let's see if we play a note. We see the whole sine changing. And it's no longer a sine, it's now a sine with another sine with a lower volume, if you like. So we see harmonical changes. And therefore it also changes very subtly, because we don't lot of harmonics here, but it does change the sound a little bit. We can also change this one into a C5. Oh, sorry, changing the wrong button here. And now you hear that there are indeed subtle changes going on. And now I can use, for instance, the phase modulation. And now you see how the LFO modifies the phase. And you can get some interesting transformations of a sine wave by toying around with these phases in some way, shape or form. And yeah, the more complex the waves you add with phase modulation, the more rich the harmonic changes will be, and yeah, can be very nice and very useful. In one of my future tutorials, especially around the sawtooth and the triangle and the pulse wave oscillator, which I have developed. The pulse wave is, by the way, not yet released, but that will happen in, I think, a week or so. Those waves are far richer in harmonics anyway, and phase modulation becomes even, yeah, let's say more rich in its application. But you can see that with sine waves you can do a lot of things, especially if you start to combine multiple sine waves with different pitches. Again, it's something you can toy around with and see how you like it, but it's usually fairly subtle. It's not as diverse as a filter, for instance, but the more harmonics you have, the more interesting phase modulation can actually work. All right, that's about phase modulation. The last thing I would like to discuss is, I'm going to add another sine wave here, is that you can also use not just an LFO to modulate things, but you can also use a Sine VCO to modulate another Sine VCO. So what I'll do here is that I'll take the output of the second sine and I'm going to use it to modulate the frequency. Actually, let me stick to the right color. I'm going to modulate the frequency of my sine wave of the first VCO with the sine wave of the second one. They both have the same pitch. So let's put the single sine wave, and now I'm going to add, and you hear that it gets richer. And if we look at, let me zoom out a little bit here. If we look at the equalizer and increase the frequency modulation, you will see that we are adding harmonics. And that's because we are modulating our sine with a high frequency signal, basically the same frequency as we are using as our base pitch for the original sine wave. So we are actually now in frequency modulation domain, FM synthesis if you like. And yeah, I can increase the volume here to make the effect even a bit more stronger, and then you see the harmonics raising. If I change the volume, you see the harmonics going out. The ones that you see peaking up here are an aliasing effect because the VCOs are not alias free. But you can hear that it has some very interesting sound effect as such. And then you can use an LFO again to modulate, for instance, the volume or even the phase or other bits and pieces, and you can really shape the way the wave looks like and the way it will sound. It becomes even more interesting if we change the frequency of the second oscillator to 1 octave higher. And then you see the the harmonics spreading out a bit further. Oops. And yeah, it becomes quite interesting to do it like that. Sorry, I swapped it out here. And you can even add another VCO and use that one to modulate the first VCO again, or even the second VCO. So you can build your algorithms if you're more familiar with FM synthesis, like in the DX7 or in the Korg Op6. You can build your own algorithms and just see how things are influencing. And again, you see here at the equalizer, we are adding more and more harmonics. And now the phase modulation becomes also richer. Like I said, the more harmonics you have, the more interesting phase modulation becomes. So if we now add the LFO again, I shouldn't have thrown it away, but let's just add, let's say some phase modulation. Where shall we add it? Let's say here. And then if we toy a little bit with the attack and we add a little bit of reverb. And maybe change this one to a C3. Well, I think I've proven that you can build some interesting sound with even something simple like a Sine VCO. At the moment you start toying around with phase modulation and frequency modulation. Last remark, if we change frequency modulation to volume modulation by using the same frequency, you actually get into the realm of ring modulation. And as you can hear, that can also give some very interesting sounds. Like I said, experiment. I think there's some nice stuff to go on. Bear one thing in mind: if you add too many signals, bear in mind that the volume can also increase, because you're basically adding signal on top of signal on top of signal. So keep your levels under control, and if you're not sure, put in a limiter, which I've not done here, but it is wise to put in a limiter, because otherwise the volume may become a bit too loud, and you don't want to have any hearing damage. Again, more of this stuff with the other VCOs in due time. I hope you find this video interesting. Let me know if you have any comments. Thanks for your attention, and I hope to see you soon.